Oxyacetylene welding/gas welding. Oxyacetylene welding, commonly referred to as gas welding, is a process which relies on combustion of oxygen and acetylene. When mixed together in correct proportions within a handheld torch or blowpipe, a relatively hot flame is produced with a temperature of about 3200 C. The chemical action of the oxyacetylene flame can be adjusted by changing the ratio of the volume of oxygen to acetylene. Gas welding is a welding process that melts and joints metals by heating them with a flame caused by a reaction of fuel gas and oxygen. The most commonly used method is oxyacetylene welding. Due to its high flame temperature, the flux may be used to deoxidize and cleanse the weld metal. The flux melts, solidifies and forms a slag skin on the resultant weld metal. Oxyfuel gas welding of W. Group of fusion welding operations that burn various fuels mixed with oxygen. Of W employs several types of gases, which is the primary distinction among the members of this group. Oxyfuel gas is also used in flame cutting torches to cut and separate metal plates and other parts. Most important of W process is oxyacetylene welding. Oxyacetylene welding or fusion welding performed by a high temperature flame from combustion of acetylene and oxygen. Flame is directed by a welding torch. Filler metal is sometimes added. Composition must be similar to base metal. Filler rod often coated with flux to clean surfaces and prevent oxidation. Acetylene CH. Welding process that uses fuel gas combined with oxygen to produce flame. This flame heat melts the metals at the joint. Acetylene fuel is used in gas welding process. Most popular fuel among of W group because it is capable of higher temperatures than any other up to 3480 C 6300 F. Two-stage chemical reaction of acetylene and oxygen. First stage reaction in a cone of flame. CH plus O, 2 Co plus H plus heat. Second stage reaction outer envelope. 2 Co plus H plus 1.50, 2 Co plus HO plus heat. Gas welding. Sound weld is obtained by selecting proper size of flame, filler, material and method of moving torch. The temperature generated during the process is 3300 C. When the metal is fused, oxygen from the atmosphere and the torch combines with molten metal and forms oxides, results defective weld. Fluxes are added to the welded metal to remove oxides. Common fluxes used are made of sodium, potassium, lithium and borax. Flux can be applied as paste, powder, liquid. Solid coating or gas. Gas welding equipment. 1. Gas cylinders. Pressure. Oxygen 125 kg/cm2. Acetylene 16 kg/cm2. 2. Regulators. Working pressure of oxygen 1 kg/cm2. Working pressure of acetylene 0.15 kg/cm2. Working pressure varies depends upon the thickness of the workpieces welded. 3. Pressure gauges. 4. Hoses. 5. Welding torch. 6. Check valve. 7. Non-return valve. Welding torch. The torch assembly consists of the handle, oxygen and fuel gas valves and mixing chamber. Welding tips or a cutting attachment can be used with the handle, allowing it to be used for welding, heating and cutting operations. Oxygen and fuel gas flow through tubes. inside the handle which blend in the mixing chamber or tip. It is at the tip that the mixed gases are ignited. Welding practice. Steps. Prepare the edges to be joined and maintain the proper position. Open the acetylene valve and ignite the gas at tip of the torch. Hold the torch at about 45 deg to the workpiece plane. Inner flame near the workpiece and filler rod at about 30 to 40 deg. Touch filler rod at the joint and control the movement according to the flow of the material. Types of flames. Oxygen is turned on. Flame immediately changes into a long white inner area feather, surrounded by a transparent blue envelope is called carburizing flame 3000 C. Addition of little more oxygen give a bright whitish cone surrounded by the transparent blue envelope is called neutral flame. It has a balance of fuel gas and oxygen 3200 C. Used for welding steels, aluminium, copper, and cast iron. If more oxygen is added, the cone becomes darker and more pointed, while the envelope becomes shorter and more fierce is called oxidizing flame. Has the highest temperature about 3400 C. Used for welding brass and brazing operation. Neutral flame. The neutral flame is produced when the ratio of oxygen to acetylene in the mixture leaving the torch is almost exactly 1:1. It's termed neutral because it will usually have no chemical effect on the metal being welded. It will not oxidize the weld metal. It will not cause an increase in the carbon content. Oxidizing flame. The oxidizing flame results from burning a mixture which contains more oxygen than required for a neutral flame. It will oxidize or burn some of the metal being welded. Carburizing flame. The carburizing flame, as its name implies, is created when the proportion of acetylene in the mixture is higher than that required to produce the neutral flame. Used on steel, it will cause an increase in the carbon content of the weld metal. Advantages of oxyacetylene welding. Advantages. It's easy to learn. The equipment is cheaper than most other types of welding rigs, e.g. TIG or MIG welding. The equipment is more portable than most other types of welding rigs, e.g. TIG welding. Oxyacetylene equipment can also be used to flame minus cut large pieces of material. Disadvantages of oxyacetylene welding. Oxyacetylene weld lines are much rougher in appearance than other kinds of welds and require more finishing if neatness is required. Oxyacetylene welds have large heat-affected zones, areas around the weld line that have had their mechanical properties adversely affected by the welding process.